Welcome back to part 2, implementing a linked list data structure in Golang. In part 1, we have seen how to declare a linked list, what it should contain, how to insert items, and how to fetch items. We have a insert at, and we have a get at any position. This is what we have implemented so far. They only handle the happy scenarios when you want to insert in the middle. But what happens if we treat also the edge scenarios, the edge cases? We have definitely handled what happens if the list is empty. Of course, if the list is empty, then the head property will be nil. However, we have another edge scenario here. Let's write the corresponding unit test to understand what the problem is. What if we wanted to insert at the head element in a linked list that already has some elements? Essentially, we will have the head pointing to an element, pointing to another element, and so on. But if we want to insert another element as the head, this one will become the new head, and everything that was before in that position would be moved with one element. So let's write a test that will show this problem, because our code doesn't currently cover it. So func test insert at head, and we have, of course, we have a new chess match, and then we have some data insert at 0, and then we insert data. And now, essentially, we want to insert another element again at 0. We will see what happens. If c.head, first of all, the element has to exist. Or if the data of the head is not m2 data, which is the expected, then we must throw an error. And we say expected element at position 0. And 2 data. Let's see what happens right now. Go test. So we have a fail because we have not handled this scenario. Let's go in the insert at. We have covered when we want to insert at any position that is not 0. Why do we know that? Because we are basing our algorithm on the previous element. But if the position that we want to insert to is already 0, there is no previous behind 0. Right? So we must handle an edge case before we enter this scenario. So if index itself is 0, first of all, we need to keep a reference to the head. Then we need to create a new element at head. So we will make a new move with data. And then we will be storing the previous head as the next property. And then we are done. This will be the handling for the scenario when the index is 0. So let's see our test now. This was previously failing. Go test. All right, so now it works. Another interesting test that we should do, and we should always be concerned of these edge cases when we write unit tests, is what if we try to insert at a position that is simply not there? What does that mean? Well, what if I have a list with 2 elements and I suddenly want to insert at position 10. So let's write a unit test and let's see what happens. Func test insert at out of bounds. Right? So we are out of the bounds of the linked list. Then we will insert at the position 0 in data. But then what if we want to insert at position 10? It's completely random. Could be anything. The other data. What should happen here? Like intuitively, I think a good handling in this scenario is if the position that you demand simply does not exist. How about you look at what's the real last position and insert after that one? At least the program will not crash, and you will still have the element. It will just not be at the demanded position because there is no such position. But clearly, the intention was to add the element somewhere at the end. You can also throw an error if you want. You could say, you know, this cannot be done. But I think a good handling would be to treat it as such, that you still insert the element, but at the real final position. So then the last position that I would expect the M2 data to be at is 1. So now we will expect the element M2 data. Then if dot get at position 1 is not, first of all, if it's nil, or if the data is not M2 data, which is what we expect, then we should throw an error F, and what we expect there is M2 data. Okay, let's see the test. Clearly it is failing because this is an invalid memory address or nil pointer dereference. Where could this be? Let's see. Let's try to understand. If we go and look at the insert at method, let's see what happens here. So when we say, give me the previous, we are basing our algorithm on the previous element. Does previous even exist? So we should check. If previous is nil, that means we have entered this scenario. When this happens, we should actually consider previous as the last element that actually exists in the list. Is see that get last. And then what happens is that the previous will be assigned to something, then our algorithm continues with this line, which is safely creating a new move and assigning it to the previous.next. Now, get last, we also did not implement it. So let's do it now. How would we get the last element? Well, first of all, let's think a bit. If there is no head, then we'll just return nil, because we don't have to return anything if there is nothing in the list. Then what we need to do, remember that in this list, the last element is always the one where there is no next. So we need to find that element. So we should iterate current is c.head, because that's where we begin. And then we say for current exists, and as long as there is a next, we are not interested in the element, because we said we are only interested in the element that has no next. Then at some point, the element will no longer be containing a next. So then we just return current. Let's see the test now. The tests are passing. One thing that we could also test, test get at head position. And then we have two elements in the list. What happens if we actually look at position 0? Of course, we would expect element and data. Let's test if actual is nil or actual that data is not emp data, and something was wrong. Then we throw an error. Let's run the tests. It's good to try to handle all the edge cases. Also, we have tested insertion at out of bounds. What if we also try to fetch at out of bounds? Test get at out of bounds. If we insert an element, what if we try to look at position 10? Maybe we should be getting nil back. When we attempt to get at a position that does not exist, we should simply not crash the application. I would expect that actual is nil. If it's not nil, okay, let's see the test. Let's now also write the functionality to remove an element. First of all, let's write the unit test. We have func test remove at head. And then now let's remove the position 0. So we remove the head element. What would be the expectation here? Well, the expectation, since you have added two elements, if you remove the first one, that means the second element becomes the head element. Let's test what we have as result. We would expect that it's the second one. If it is not so, so if actual is either non-existent or actual data is not the M2 data, then we just throw an error. Okay? So let's think about it. If there is no head, then the list is empty. We just return. So we will store a reference to the previous element, previous c.get at index -1. If there is a previous, the previous also has a next, then the next of the previous will actually be the next of the next, because we have simply removed an element. Let's see what the test says. Test remove at head has failed. So we have added this handling to remove the elements. But again, we have not handled the scenario when there is no previous. There is no previous when you want to remove from the first element. If index is actually 0, c.head is simply what was after it, c.head.next. And then we return. So we just remove what was c.head. So let's see the test now. Okay, so let's write another test. Func test remove at random position. So when we have 4 elements and we insert all of them, what if we want to remove at position 2? Position 2 would be this, M3 data. Then we would expect that M6, M2 data points to M4 data, right? Then we need to get position 2. So what's right now at position 2 since we removed it? What we expect the M for. If there is no actual or does not correspond to the expectation, then we throw an error. Okay, let's see what the test does. And it's working. What if we test removing at the last position as well? Because we need to cover all edge cases. Let's remove that last position. So we have 4 items. We insert all of them. What if we remove at the last position? What would we expect? We expect that the last one now is position 2, which is M3 data. Now c.get last. Oops. Get last. And if actual last is nil, something went wrong, or actual.data does not correspond to our expectation, which is M3 data, then we should throw an error. Let's see what the test says. Go test. It's working. We also should test, let's also test removing at out of bounds. Func test remove that out of bounds. And then we have one item. What if we want to remove at position 20? Here I'm not going to write any actual assertion or any assertion at all, because essentially I want this test to pass. This is how you test that an exception was not thrown in Golang. You just don't write an assertion. And if it fails, then the go test command will fail simply. Let's see. Go test. As we can see, it works. We said that we will want to implement a method where we iterate our list and we run some action on each element. So let's write a unit test. Func test for each. Alright, so if we have a chess match with 3 elements, what I want to do is run a function. Let's initialize a property that says new data is modified data. And I want to pass here some function. Remember that for each receive a function which operates on the type pointer to move called predicate function. So we should create a function now that changes one element data property with the new data here. So let's do this. We will say we want a variable modify data function is a func which takes an element of type move, and then what it does is element.data is new data. And then we are going to pass this function in here. Okay? So I had some data in the elements, but now I'm saying for each element, assign the new data, which is this one, to their data property. So replace all the data that they have with this one. Let's complete the unit test. So we will have actual one is c.get at 0. What we want here is that actual one.data is new data. If it's not so, something went wrong. That means our function simply does not work. When we say error, we should say expected. Okay, let's run the test. Go test. So we can see it fails on the for each test. So we just want to iterate the list actually, and we just want to apply the function for each item. So first of all, if c.head is nil, we should just return. To iterate, as we have seen before in the previous implementations, we need to keep a reference to the current iteration. So current is c.head because that's where we start with the iteration. And then we have for current exists. So what we do is we take the predicate function and we apply it to the element. Okay? And then we go to the next element. We reassign current with the next from current. So what this does is it will, as long as you have a current, apply the function and then reassign current to the next one. Let's see our test now. Go test. Bam, and we have solved this one as well. How would we use this for each? For example, you would, in the scenario that we have here with chess games and whatnot, you could have maybe a function that says replay match. What would that be? You know, maybe you want to just print all the moves from that match. For each move in the list, print move, right? So we will have something like print move is just a function which operates on a pointer to move, and what it does is simply it formats the data. that will be it. Okay, this was a bit long. I hope it was fun. I think the unit tests make it really fun to prove the hypothesis and ensure that you really have every edge case covered. Thank you very much. See you in the next one. Bye.